Hello everyone, welcome back. This is Professor Xiao. Let me first review what we talked about last week. The focus of the last week was a case study. It was about customer churn problem of a telecommunication company. I mostly focused on the conceptual analysis of the associations or correlations between the target variable churn and various input variables. The target variable is a binary variable, whereas there are different types of input variables. I conducted analysis between the binary target variable and the categorical input variables, as well as the continuous input variables. I mentioned that binning could be very useful in the analysis of the association between binary target variable and continuous input variable using visualization. Those analyses are mostly conceptual without taking a look at the data set. So in this week, I'm going to focus on analyzing the data. We will dive into the data, connect the data to the conceptual analysis that I went through last week, and I will demonstrate how to make those different visualizations in SAS Enterprise Miner. Now let's get started. A little bit of an overview of the process model. What is it that we're doing today, and where is it in the process? What does it do? Beginning next week, we'll start talking about modeling. The modeling is the coolest part of data mining process. It's something that got you hooked up with this course in the first place. Finally get to see it. Before that, there's a little bit of preparations in terms of transformations, and not so much cleaning, because we did cleaning in the first homework and missing values analysis and so forth. And then the model stage. Today is understanding and a little bit of preparation. Following the modeling, you get the results. You need to evaluate and compare different models on different criteria. Some problems involve decision making. How to prioritize the decisions and the profit is another aspect of it. But all of these depend on that you have good understanding about the data. So that's what we're going to do today. EDA stands for Exploratory Data Analysis. What is this association? What do we call it in other ways? Correlation. Great. Association. Covariance. So what is correlation? Correlation doesn't have to be causation. Somewhere causes the two to co-change. It doesn't have to be one causes the other. Data science or data analytics in general, we don't try to tackle scientific questions. We don't try to find the cause. It would be very hard for you to try to find the cause because you are limited in terms of data set. You can't run experiments, can you? No, you cannot. We try to use graphs, visualizations, histograms, those tools to try to understand relationships between a few variables at a time. Because we are humans. We can't take 10 variables at a time and do a 10-dimensional space exploration. You start with a few variables and move on to different variables. You can find those variables that are more important than the others. That gives you some pointers as to how to construct the model. Hypothesis testing. In business, sometimes it helps, especially in marketing. Sometimes you try to diagnose a failed product. So you start asking why. Why does it fail? Why does the market not respond to the product, right? And then you need to do some customer segmentation analysis, customer profile analysis, and demand analysis, and some market level analysis. About all of those effects, if you have data, you can test. Hypothesis testing helps you better understand the phenomenon. If you try to find the causal factor. So EDA is good for getting to know the data set, to delve into the data set, to examine relationships, to allow important variables to surface at the very early stage, and also for you to discover problems with the data set, right? This is the data set as you're familiar, right? Everybody has completed homework 1. This data set has 3,000 rows. It's about customers' churning behavior and a bunch of input variables about their accounts. And this is a list of variables. So we're going to focus on that today. We need to set up the SAS environment. You probably already have, so you don't have to do it again, but if you want to do it again, feel free. You will use this data set to finish several homeworks, I believe, at least 3 or 4. So you can recycle the same project in SAS EM. So I'm going to create a new project. So yeah. Right. Okay, I need to do the library. I need to do the data source. So you know the drill. Okay, I want to make sure that your data source is set up in the same way as I do. If you are starting over, you can simply follow and make sure we're doing the same thing. Wait, hold on. Wait, here I'm starting to mess around with the advanced. So customize. If you do from fresh, make sure you do the same. Wait, I'm going to change 30. I'll explain why. 10 and 100. So what I'm doing here, this is the step right before I customize the rows and levels of the variables, right? If I didn't do this, if I chose basic and I go next, the next page would be a list of variables for me to change the levels and rows, right? So this step is going to directly affect what is specified in the next page by SAS, right? So SAS try to do some guessing game for you and try to lower the workload for you. That's why you didn't have to change a lot of things, right, on a page of variables, but sometimes you still need to change. Like for target, you have to make sure there's only one target and one and only one target. You need to make sure that the phone number has a appropriate role, right? The phone number in the first homework, what happened to the phone number? Yeah. What if you include as the input? What happens? What will happen? You probably don't know, but if you don't know, that's fine. But if you knew, let everybody know. If you included phone number as an input, that means the model will try to evaluate phone number as an input, assuming that the information about the phone numbers, the digits, has some information in telling whether or not the customer will churn. Do you think that will happen? Your phone number tells me who you are, how you're going to behave, and your fate.
The area code can.
Huh?
The area code may be good.
The area code, yes. Here, the phone number and area code is separate. So we have the area code and have the phone number without the area code. Yes. It's a good point. Yeah.
So-
Without the error code, what do you think?
So if it's just a phone,
So it can be considered as a random number.
so should we have rejected that and not work? That would have been the right answer.
Well, let's see. So there are two approaches. You can set it as ID, and it's good for an ID column because phone number is unique for every customer. We typically need an ID. So instead of creating a new ID, we simply use the phone number. Or that's the other way. You know, you reject the phone number, you create an ID, or leave ID blank. Else. But if you had included phone number as an input, then it's a large number. If it's numeric, it's a large number. So it's millions, right? 7 digits. It's millions. So it's a lot of computing load for the computer. Resources used on useless information. So that's waste of resource. If in some cases the phone number as an input had a row of nominal, then you're thrown an error. You have reached the maximum number of levels. The level is 512, and then you get confused. So anyway, the best practice here is to set the phone number as ID. Here, I changed the first threshold. It tells Sas to examine each of the variable, right? And if Sas found over 30% rows as missing, Sas will automatically reject the variable. So this is the threshold I can change. You need to decide what level of missing you can tolerate, right? If you can tolerate higher, you set it higher. You set it 70%. Anything below 70% missing values, you can still tolerate. But you need to know the level that you can tolerate. Here, I'm making 30, so that's 30%, right? If Sas found over 30% missing in one column, this variable will be rejected automatically. So that's what it does. Class level count threshold. Can you guess what it does? So in empirical data, right? If the column is numbers, say 1, 2, 3, 4, 5, 6, 7, think about age, right? 18, 19, 20, 23, 55, 68, 47. I'm making up numbers. What does this do? What do you think? So I still have to tell Sas if the number, the column, is interval or nominal. I have to tell Sas, and you have to make it right? For age, what do you think? It should be nominal or it should be interval? Think twice. Yeah, interval. Age, because the scale is it's continuous. And for Sas, it doesn't matter. But for Sas, what it means is that there are typically more than 10 unique values in interval variables, right? Think of age. How many possibilities can you have? Maybe 60 at least, from 18 to 78. That's 60 possibilities. But it can be more than that. But let's think about gender. What level do you think gender should be? Two or three, but level, the type, it's nominal, right? It's class, it's nominal. It's nominal because it only has 2 or 3 levels. So that's what this threshold does. For any variable that has more than 10 unique levels in the values, assuming it's numeric, If it's string, it's automatically class. But if it's numeric, it may be vague, right, for SAS. So this number tells SAS that if SAS detected more than 10 or more than 10 unique values, it's automatically interval. That makes sense, right? If it's below 10, it's automatically class. And you will have to think about this data set particularly. Does it make sense, right? If it's a different data set, you might have to change it to 15, because you might have a class variable that has 12 levels, and you still want it to be class variable. That make sense? Mm-hmm.
So that's how you decide, by looking at your data first and checking?
Yeah, it kind of requires some knowledge about the data set, but other things, the common sense, right? So that's the second number. The third number, try to take a guess. What does it do?
If it has X number of levels, it'll be eliminated or rejected?
Mm-hmm. Can you think about an example? Do you remember what was the value before? I think it was 10? 20. Oh yeah, it says default value of 20. Yeah. So think about for state. How many levels do state have? Typically 50, right? 51, 50 or 51. Can you imagine that if we left this number at 20 and we go forward, what will happen to the state variable? It will be rejected. So that's why I increased it to 100, so that state will not be rejected, right? So are we all clear on this page? So this is not super critical. It's helpful, right? It's helpful if you have a large data set. If you have 1,000 variables, God, how far you can imagine. If you only have 20 variables, you can always change one by one, right? So let's take a look. Phone number is rejected automatically. It wasn't if I hadn't done the advanced step. Why?
It's over 100 numbers.
Yes, exactly. First, it has to be nominal first, and then the number of levels exceeded 100. Yeah, so it's automatically rejected. So that means what we changed has taken effect. But here I wanted to do ID, so I simply changed that. So I'm not criticizing SAS. SAS is helpful, but I want to do something different. That's basically it. And we there's another thing we have to change. SAS didn't guess which one is target, but there wasn't any information for SAS to guess, right? So it couldn't, it's not a good expectation. So you need to go ahead and intervene and change that to target. Turn. What else? Everything looks good. Area code nominal. Let me change it to interval for now. Let's see. That should be good. So make sure you have the same settings as I do. So decisions, we're not going to do decisions now. And straight through, yes, and finish. All right. Now I'll create my first diagram. drag the data source. Data preparation includes generating graphs, visualizations, or analysis, descriptive analysis of the data set. So we haven't even started the visualization yet. So everything we do today is the preparation and as well as understanding. Let me go back to slides first. This is a snapshot of the data set. It's taken from the spreadsheet. Those are the typical format of the different variables. We have a phone number is in string type, so there's a dash inside. It can be numeric. And international plan is very likely to be binary, as well as Vmail plan. All the minutes, calls, and charge variables seem to be numeric, and there are decimals. There are day, evening, night, and international. There is a number of customer service calls, seem to be also numeric, but with small numbers. There's a state variable. Begin demo in Sas EM. We kind of took a look at the data set already. Let's try to find these insights. The variable phone uses only 7 digits. So we saw that in the previous slide, but is that true in the data set? How do you find out? Right? How do you find out in Sas? There are 2 flag variables that Sas guessed it. Most of the variables are continuous. The target variable is a binary that has 2 values, true and false. We can also find out. The meaning of churn is that they left the company. Just to be sure, everything inside this data set describe the information and the behavior of those customers in the past. These are what already happened. It's not something that's going to happen. How to find out the values of the phone? How do you see the values? Imported data. Yeah, now it's there. You can browse. Or you can browse the data set. Then you have the phone number. Yeah, it's 7 digits with a dash inside.
What is data type?
The type. Okay, it's a little bit technical. The level is nominal. Yeah, because every value is unique, right? Phone number is unique. The exact type in the storage, I guess it's strings, characters. But you can still sort, right? Based on these.
Strings?
String is character value.
String, right?
Yeah.
STRING.
Yeah. So this is where you can look at the data set, and in every node, almost every node, you can access the imported and exported data set. You'll see the same view, but not the same view, but you'll see the updated data set at that point, right? Because imagine a data set is passing through the process, but changes are being made to the data set. Right. So we confirmed that. Now, getting to know the data set a little bit. There's one node that I said is very useful, that you can use that tool to quickly see the distributions of every variable in the data set. What is it? Transform variables. Yeah. You'll be very clear on that because that saves you a lot of time. And plus, that node can do other things. So that's what we're going to do here. We'll quickly take a look at the distributions, as if we're doing something like this. You can see the distribution right away for all the variables. Right, where is transform variable? It's under modify because it's making changes to the data set. And the nifty tool of transform variable is within the formula. before you do that, it will ask you to update the path. So might as well just do that. So now under the train, there's a formula. We go into it. This is where you can quickly browse the distribution for all the variables, right? You go from top to down. It's very fast. It's almost instant. Even if it's a large data set, it's going to be instant. I want to show you something here. It's quick, it's fast. You might think it doesn't allow many customizations, but you can still customize the graphs. So let me show you something. We have a customer service calls, right? It's typically 0, 1, 2, 3. So you can see the range is between 0 to 9. But you have a bar which is between 0 and 0.9, and a bar between 0.9 and 1.8. It's kind of weird. You know, number of service calls is typically integers. There's no decimals involved, but it just made it that way because there are only 9 levels, or 10 levels, but 9 bars are being made, or something like that. So we can change that to make it better for reporting purposes. So what you can do is you can right-click. Graph properties is to change how the graph is rendered. There is a bin tab, which is already highlighted. Horizontal bins, we only have horizontal bins now. It turns out that there are 9 levels, not 10, but 10 was being used, which breaks the integers into decimals. So if you use 9, and do apply, what do you see? Those tick marks are, aligned and well and looking very good. So that's a trick you can do. But see this. So I'm on customer service. I go up, I go down, it goes back. So just know that everything you do here is not saved. Okay, there's one thing I forgot to do, which happens a lot. You started doing something and you realize something you didn't do, and you have to go back. The graphs that the transform variable made is based on a sample. So think in the shoes of Sas. Sas couldn't assume. It can't assume every data set is reasonable size. Sometimes the data set is like trillions of records, and it doesn't assume that your computer can handle every data in memory on the fly. So it automatically takes a random sample of any data set and do graphs based on that smaller sample. But that's good, just to be prepared, right? You don't want users to forget to do that, but then the software hand trying to make some graph of the entire data set. That's not good for Sas and for the user. But here we have a smaller data set. So we want to use the entire data set. That's almost true, always true for the entire course, right? So hopefully you form this habit. Whenever you do the exploratory tools, always take the entire sample. There's something you need to change for the transform variable. Here in the sample properties, change it to max. Change it to random, and then modify the size to be max. So that assures that every time it takes the entire sample. And you need to update the path before you go into the formula again, right? Great. And let's see. Going to the formulas. Explain interactions. Okay, great. Question?
What's the difference between updating and running?
Yeah, updating. At least I'm not super very clear on answering the question fully, but at least I'm sure that updating will transfer the data over to this node, but running will do everything that you tell the node to do. So updating is typically faster than running, to finish. But if you do update, it doesn't do everything, at least. Let's see. Do we need to run? Go to Formula Explorer. I think we're fine. Okay. There are several other tools here under Train. There's interactions here. So I'll briefly explain what it is. Interactions is for you to create interaction terms. If you know about regression, then you know that you can multiply some variables together to make a new variable, right? And that is sort of introducing an interaction term. So this is where you do it. You can go to interactions, and you can, let's see, I want to make a term, or I want to make a new variable, but that new variable is based on two existing variables, right? It's account length times customer service calls. So I will drag those two variables over and save, and then it makes a product variable between the two variables, right? You can check the values. I'm sure they are correct. So if you do that, and now you have to run because you're making some significant change to the data set. And after you run it, you take a look at the exported data set. You will see the new column is the product between the two variables I just did. So that is good, but I'm going to delete that. I don't want to do that. I'm just illustrating. And one more thing. So there is a very cool function here. Actually, it's there in every node, but we don't use it. There's a Sas Code Node, which gives you more control on what you want to do about the data set. This is the window to SAS programming. Right? If you want to program, then you go through the SAS node. So has anybody had any SAS programming experience? Oh, you do?
Yeah, I learned it a little bit online. I just watched some tutorials and learning some.
Yeah. Great. Is that something that your company wants?
Not exactly. I just learned by interesting.
Okay, great. Yeah, so SAS programming has two types of operations. One is data, the other is process. Right? Data is where you change data. Process is where you do some analysis. And the programming language of SAS would be different because you won't see those. The interface will be different. But as far as coding, it's going to be similar. So in terms of the IDE, the integrated developing environment, the color coding thing, right? As soon as you type, it will change color if you use keyword. Like data is a keyword. Then you create a new data and you can use the library. Your mylib dot is a library terminology. So you create this data and semicolon at the end of line every time. So data creates the new data set. Is always, almost always, you create a new data set based on an existing one. So set is by copying an existing data set. So this is just a show in Sas, basically. It's not something important. And run, then you can run it. These codes don't make sense, but I'm just randomly typing. But the keywords are right. Like if the keywords are right, it will be color coded. So you have this level of control if you know Sas. Transform, and the last one will be that what you do about those variables in terms of transformation, right? You can log transform, you can standardize, right? You can do z-score standardization, as in homework. You can do range standardization, which is min-max standardization. I think that's mostly it. Method random. Yep. Okay. Yeah, I would like to go into the distributions to take a closer look. So we want to take a look at the distributions and to find out those variables that are skewed distributed. You know, those variables that you think is highly skewed, and call their name. Wait, hold on. So this is account length. Is it skewed? Yes? No? Slightly. It's I think it's benign. It's okay. I'll let it go. Area code? What's going on? It's a big gap. We'll leave that alone for now. Turn is binary, so it doesn't make sense for skewness. Customer service calls, what do you think? Just call its name. Just, customer service call is skewed.
Right skewed?
Right skewed, yeah. Even better, much better. Yeah. Okay, day calls. It's the calls that happen in the day. Left skew slightly. It's fine. It's okay. It's okay. Yeah. So, you see what I'm doing? So I'm switching back and forth between day charge and day min. What do you notice? Value changed, yeah.
But the graph is the same.
Distribution is the same. Are you sure it's exactly the same?
No, it's not exactly.
Oh, wait, other than the ranges? The shape? It's the same. Why?
Because you get charged for the number of minutes you talk.
Say that again?
You get charged for the number of calls you make, because day calls is like the length of your call or how long you're talking, and day charge is what you're getting charged for that. So if you're calling for a minute, you get charged for a minute. You're calling for 10 minutes, you get charged for 10 minutes.
Does that make sense?
Yes.
Yeah. Fully correlated. They are mechanistic relationship. It's mechanical. It's so in other words, you can suspect that the rates are fixed. Does that make sense? The rates are fixed. A charge per minute is fixed, right? So the more calls you make, or the more minutes you use, the more you're charged, and the rate is fixed, right? What about cause? Yeah, I'm switching between cause and charge. Cause and minutes are not exactly the same, or related, right? Sometimes you make a longer cause, sometimes you make a shorter cause. People are different. So as I switch in between those, there's some difference between the distributions, right? Oh, let me go on to evening cause, slightly skewed, evening charge, and evening minutes. Wait, I always hit the touchpad. Let's see, evening, blush, evening minutes and evening charge. I'm switching back and forth. It's the same. And night, international minutes and charge. Similar, but not exactly. So you can kind of imagine that there's a little bit more going on here for international plan. It's not a fixed plan, but it kind of changes a little bit depending on how much you use it, right? It's like dynamic rate. You can call it dynamic rates. The more you use it, the per minute charge may drop a little bit to encourage people to use more. That makes sense? That's a marketing, sort of a tactic. The more you buy, the higher discount I give you. The tiered, it's like the tiered rate. International plan, night calls, night charge, and 9 minute, almost identical. And states, across 50 states. Voice message. Great. So I had a question. There's a big bar to the left, and what do you think is going on?
A lot of people just don't have voicemails, or maybe they didn't activate their voicemail box.
Either they don't have voicemails, or
Either no one left them voicemails, or they just don't have a voicemail box. They don't have
right. They might not have the service, but the range is between 0 and 5. It doesn't necessarily mean it's 0.
Yeah.
It could be 1 still, right? How do you find out?
Expand the level.
Yeah, Sean's right. Adjust the bin. I have between 0 and 51. 51 is the maximum. So if I had made 51 bars, then I would clearly see what is the number 0 that is the spike, or is it number 1, or is it multiple numbers, right? So if I make 51 bars, every integer will have its own bar, right? So you know how to change the bins, right? I just showed you in customer service call. You right click and go into the property graph property. You can change it to 51. See? So now it's getting better. So which value do you think is the mode? Yeah. Now it's clear. It's not 2, at least. It's not 1. It's 0. So those people have a value of 0, and they are the majority of the sample, right? And mail plan. Now it's gone. Anyway, so these tools help me answer some questions, and rather important ones, at least at the very beginning stage of analyzing the problem, analyzing the data. So, one thing, the reason this tool is formula is you can use a formula to create new variables. Because you can create new formula here, and you can, do the simple math. You can do plus, minus. If you want to shift any variable to the right by 5, you can add 5 to that variable and make a new one. So that's why it's called formula. And then they make it so nice that I think the distribution tool is much better than the formula. It kind of take over the purpose. But anyway, you can do that. And there's something we can quickly check here, is to check the rates. So I will create the rate variable, let's say day. How would you do that? Division, right? What divide what by what?
Calls by charge?
Call by charge.
I don't know, minutes, but
Yeah. Charge by minute, exactly, right? So charge is the product. So yeah, we can do that. If you remember the variable name, you can simply type. Otherwise, you can select. You can build. I'm going to type as I know. So this variable is day charge divided by day minutes, and its name is called day rate. See, that's changed, updated. When I do OK, a new variable is created with the labels and type appropriately set. You can check the formula again to make sure. If I had a typo, that won't go through, I think. So this means it went through. And so this time we have to run it. Results. Now the operation used 2 variables to create a new variable, right? And what do you expect about the rate? It should be all the same value, or very close values, right? So what can I do? Here, I can make some plot and do a histogram with the new, bad place, sorry. I need to go to the exported data. Do explore, do the graph, or we can browse it for a moment. The rate is all very close to 0.17. It's not exactly 0.17, but because of rounding, probably. And then I can do a graph of histogram and use the rate as x. You see the values are highly concentrated around 0.17. So that confirms the notion, right? Sometimes you can't get a hold with the company to answer some of your questions, and you can get those answers from the data. The data tells you a lot that sometimes even a company can't tell you. If you know how to work with the data, right? Does that make sense? Can we move on? Good. Yeah, I've already made you sleepy. But anyway, so right, let's move on to the slides. The skewed distributions that you can find here in the slides has already been confirmed. Voicemail message has a spike on the 0 value. All the minutes and charge and calls don't have much of a skew. But the customer service call has a big skew, as well as the international calls. And that's it. So we already demoed in Sas. Okay. In terms of generating plots, transform variable is one tool. You can browse everything very quickly, but you can't save the graph. It's only bar chart or histogram. You can't do scatter chart, right? And you can't make 2 at the same time. Sometimes you need to make 2 to compare. Sometimes you need to make 2 graphs to link. Sometimes you need to analyze the subsamples. Based on one condition, you want to look at distribution on the other condition. So you need another tool. That's a Graph Explorer. Similar to Stats Explorer. Stats Explorer gives you stats. Graph Explorer gives you graphs. Before we make those graphs, we need to know the purpose. Let's back out a little bit. So what's the purpose of this project? We need to understand why they churned. We need to build a model that can predict churn. And to build a good model, we need to include the relevant variables, right? We need to understand the relationship between the inputs and the target, right? So that's the purpose. Now we can move into the analysis. It starts from the analyzing the churn variable first, right? What is the percentage that they churn? What is the percentage that didn't churn? It turns out that 15% churned, so it's not so bad. I think the target is to predict who's going to churn, right? Start to think about how other variables can be correlated with that. From previous class, we took a look at the voicemail plan and made some bar graphs and try to see if voicemail plan made a difference in terms of churning. Voicemail plan is a binary variable. Churn is another binary variable, right? Let's try to make this graph in Sas. So we're going to make a bar graph grouped by voicemail plan and try to overlay the two outcomes under these bars. So, let's see. In Sas, what do you use, right? To make that exact graph, you will use the Graph Explorer. So that's where you customize all the graphs, and you have to make graphs if you need any. But before I talk about that, there's another tool which is great, which is called multi-graph. Right, multi-graph helps you make batch graphs. Batch graphs for a particular purpose. If you want to make a particular kind of graph for every input variable and color-coded for all the outcome, like a churn. So if you want to make a graph and then color-code outcome, then you can make those graphs in batch using the multi-graph. So let's take a look. In Explore, is it Explore? Yeah. Multi-plot. Is under Explore. So drag over. There are a few things we have to change. Let's see. Oh, here, the chart type. So before you make a choice, you need to be sure what do you need, right? This is bar chart, and bar chart color coded by outcome, so sort of overlaid bar chart. Another chart is scatter plot, where you have two axes, and then you have points to indicate the coordinates of each point based on two dimensions. So you need to make a selection here. Is it bar chart or scatter plot? It's bar chart, right? So it makes a bar chart for each input variable and overlaid by the outcome. So that's what it does. And it make them in batch. And there's something else I need to change. No, for the moment, change the bins to 15. I'll explain why. And now we can run it. Doing fine? Great, let's take a look at the results. Look at that. So it's a similar chart that you found in the slides, right? It's color coded by churn. It's red and blue, and a distribution chart, a bar chart for the main variable. The variable here is account length. So account length by churn is this sort of the interlaid chart. If you can do slideshow, but it's not necessary. Scroll over the different variables. You get area code, customer service calls, day charge, and a lot. But I want to go to the voicemail plan very quickly. Okay. So this is a interlaid bar chart, but not normalized. See what I'm saying? So the chart in the slide is normalized. You have the bars with equal length. But here, the length of the bars represent the number of cases here. So the longer the bar, the more cases you have. And now, try to imagine that you want to analyze a correlation, and then you focus on the proportion of the red bar in the entire bar. Can you really compare?
No.
Because the length is different. You have to do the mental, translation to really get to the proportion first, and then you compare. But it's really hard, right? So with the raw bar, with the raw chart, it's hard to do that. That's the case when you have different frequencies of the two conditions. For some other charts, it may work, like states. So this is the interlaid bar graph of states, right? Interlaid by the outcome. The bars are roughly the same size, so you can kind of see the proportion of churn is similar across all the states, although there are some differences. For others, it may be useful as well. An international plan. Here, it may be useful because you can kind of figure out this is close to 45%, even with the dramatic difference in the bar length. You can see that the red portion is close to 40 or 45%, and in this longer bar, it's top 20. It can't be more than 20, right? So 20 versus 40, it's still big difference, right? So in these cases, you can figure out even without normalizing the bars. But as I said, it's not always helpful with these, different proportions or similar proportions but different lengths. It's hard to compare. So in the slides, in the textbook, they show the normalized bar chart. Unfortunately, in Sas, we can't make it. So Sas doesn't provide the capability to do that. But there's something else you can use, which is a pie chart. You use pie chart because a pie is normalized by nature, right? So the proportion of a piece of pizza represents the proportion of the entire group. So you can use the slice size to compare relative proportions. Let's do the pie chart, as well as let's do the same interlaid chart, but in Graph Explorer, right? So what I demonstrated just now is the multiplot, right? In multiplot, it makes the graphs in batch. It makes everything for you without you having to specify, and you have everything here. But you can't customize too much here, right? You can't do an interlaid graph between two input variables. You just can't do that. because the interlay here is the outcome. So you need more space for customization. To do that, you can use the Graph Explorer. So it's also under Explorer. Graph, the third one, fourth one. Graph Explorer. So, as well as with the transform variables, make sure that you change the sampling method and make sure you get the entire sample. And now you can run it. So it doesn't give you much by default. It gives you a graph of the target variable, so you can see the percentage of true turners is close to 1/6 or 1/7. When you highlight the bar, you have those rows highlighted in the data view, right? If you highlight the other, then the other rows are highlighted. So this is the linked graph. You can explore that feature. It doesn't give you much. It gives you an overview of the different types of variables. But you have the capability of making new graphs as much as you want, right? And the ones that you make can be saved. So this is the advantage over the other graphing tools. So to start making graph, you need to click this button. Sometimes this button is grayed out. To get that button back, you need to activate one of the graph, at least. To activate that, you can see that button. If unfortunately you lost all the graph, then there's no way you can get it back. Within the view, you have to exit the view and re-enter the node again. Does that make sense? Yeah. So now you can do that. Let's do a bar chart of a voicemail plan, right? So let's do a bar chart. You can do horizontal, you can do vertical. Your choice. The category is the two bars, right? What are the two bars? It's the voicemail plan. Allow multiple. So this is the stacked or clustered bar chart. I'll talk about that later. So without ticking this, you have no other choice. You will have to replace that one in order to choose a second variable. So for now, we're doing the voicemail plan and customize the title. X label is voicemail plan. Y should be frequency. So there you go. And you can do this. You can minimize it and then reopen it. It will reorganize the windows for you. So I have two graphs and they are internally linked in terms of the observations. Here I have the churn, and down below I have the voicemail plan. So to see the proportion of churners, those who churn, under different conditions of voicemail plan, I can simply click the true condition, right? And then you can see that it seems like those who don't have the voicemail plan has a higher likelihood of churn. Those who have the voicemail plan has lower likelihood of churn. But again, this is not normalized, right? You can only see the exact numbers comparison. You can't compare the relative percentages. So, and it doesn't give you an option to normalize the bar length. So we can't rely on bar charts, and now we have to turn the attention to pie charts. So let me demonstrate how pie chart can be better in this case. So we will make a pie chart. For pie chart, you by default you have to have a category first. The category is typically the outcome, right? It's the condition that separates the two outcomes. So that's the churn. So you want the churn to be the category, but also we want to see 2 bars. We want to see 2 pies. The 2 pies, one for each of the 2 conditions of the voicemail plan, right? So we need the voicemail plan to be the category, no, the group. And change the title. Chart of churn by mail plan. Footnote, legend. Churn. Legend is top. Legend. Bottom. Okay, so take a look. So this is stacked pie chart. It's not really 2 pies. I'm getting only 1 pie. That's not fair. Anyway, but this makes it easier for you to compare the exact percentages, right? Because they are aligned on one edge. So in the inner circle is those who have the voicemail plan. The outer circle, outer pie, are those who do not have the voicemail plan. You can clearly see which group has a higher likelihood of churn. Which group has a higher likelihood of churn? Yes, with or without voicemail plan? Without, right, the other circle, the bigger pie. So this sort of replaces the value of normalized bars, and pie charts is kind of cool. So yeah, so you have that, and wait, if you minimize that, it will try to reorganize the windows. And let's see if I will lose the graphs. So I have those graphs, yeah? So they won't be lost. Sometimes it lost. I can't say for sure, so caution. But at least for temporary, you have those.
But diagrams we can always save, right? Separately.
You can what can you save? Copy. Yeah. Copy to the clipboard. You can save
or
to.
You can go to file and save as, maybe? Try that?
Yeah, it doesn't. You can print.
Oh, right.
So limited.
Yeah,
Limited.
mine is-
You can save.
Mhm.
Are you saving this graph, or are you saving the entire node?
I think I'm saving the entire node as a result. Yeah.
So this. What does it save as? It saves as an output file. Yeah, you can try. Yeah, you can try. I don't know for sure if you can, extract it very easily into Word files or Excels, but at least you can save the picture. You can copy that. Yeah. Question?
I have a quick question regarding to the pie chart.
Yeah.
Would it be easier to see if we make 2 pie charts? Oh wait, no, that would make sense.
If we make 2 pie charts.
Because you know how it has a relationship.
Yeah. Well, if I click true,
Right.
which part do you think will light up?
The red one.
Yeah, exactly.
Okay.
So you can use your imagination to think about what graphs you want,
Okay.
and you can do multiple, layers if you want. Yeah. Other questions? Great. So I skipped these slides. I skipped the EM part for these analysis, but you can make them yourself using the same tools. For instance, this is a plain bar chart for the target variable, right? You see 2 bars and there's no colors. It follows by having an interlaid chart and interlaid by the outcome. So you have colored bars. The longer bar represents those customers who do not have the international plan. The smaller bar are those who have the international plan, right? So you can see that likelihood of churn is much higher when they have the international plan, right? Close to 40%. But it drops in terms of proportion if they don't have the international plan. So somehow international plan is making people leave, in a sense, right? So then the company definitely wants to investigate what is wrong with the international plan, or what is wrong with the segment of customers who subscribe to international plan. Are they leavers by definition? You can follow up with more analysis. Again, this is the normalized chart. We can't do it in SAS, but we can do the pie chart. And this is the contingency table. The percentages here represent the proportion of the colors in the bars, right? So you can translate between them. If you switch the variables, you can kind of imagine 2 versions of color layered chart, right? The bars can be conditions of the input variable, let's say the Vimeo plan, right? Vimeo plan has 2 bars. Within each bar, you have churners and non-churners. But you can also do churn as representing 2 bars. You have churners and non-churners. Within each condition, you have those who have the international plan and those who don't. So different perspective to analyze the correlation, but the conclusion will be the same. To get the contingency table counts as well as the percentages, you already have the tool. So let me show you. You have Stat Explore, right? You typically use it for missing values and type of variables. But you can also get the contingency table statistics. So if I do Stat Explore and make sure I have all of them, all the observations, make sure I have the interval variables changed to yes, and I can run. The first thing I did is to make sure I have the full sample analyzed. The second thing I did is to make sure that the ranking of the variable worth also includes the interval variables, not only the class variables. Okay. Now the results output, as you would expect, it has a list of different types of variables. You have class variables, you have interval variables, and within the class variable you also have the target, which is a class variable. You have the percentage of the different outcomes, which is the same as in the slide. Down below, you have the proportion of churn and non-churn under each condition of the class variable, every class variable. Let's say for state is too much. Voicemail plan. Under the condition of churn equal false, so those who didn't churn, the mode is no. That means there are more customers without the voicemail plan than with the voicemail plan. So within the false condition of churn, more customers do not have the voicemail plan. And the mode percentage is 70%, right? 70% of this group who didn't churn do not have the voicemail plan. Mode 2 is the other condition with voicemail plan, and 29% of them has the voicemail plan. So they add up to 100%, right? In the row. And the second row is those who churn. Again, more customers did not have the voicemail plan, and less customers have the voicemail plan. But you can see that the percentage of not having the voicemail plan is higher in those who churn. Right, so you can get to these statistics. Let's see. Scatter plot. I haven't shown you scatter plot yet. Scatter plot is for examining the correlation between two continuous variables, right? So let's say here, what are the two variables that you would expect to have high correlation? Minutes and charge. That would be almost perfect linear relation, right? So we can generate some scatter plot to look at the correlations. So the same place, scatter plot, and the first. Okay, we need to select X and Y. Oh, yeah, this is the bad place to be to do the scatter plot. So Stat Explorer is the only place that you can't do exploratory charts using the original variables, because it creates all kinds of stats for you to use, and you can use those stats to plot for different purposes, but not for the purpose that I need. So a better place would be Graph Explorer, but actually any other node other than the Stat Explorer. Let's go into here and scatter plot, and you have the original variables. We need to do the day charge on Y, day minute on the X. Okay, scatter plot, day charge by day minute. X is day minutes, Y is day charge. Look at that. What does it say?
The more you talk, the more you get charged.
Yeah, and it's perfect linear. It's perfect linear. Yeah, I don't like the size of the tiles. It's too big, but you can change that. You know, under graph properties, it's about the, let's see, graph. No, sorry, scatter. Auto size markers. If you don't want auto size, you can change it to smaller. And let's see, much better. Yeah, so it's a linear line of correlation. Okay, let's see. And you know, if you have a lot of interval variables, then you know you need to make pairwise scatter plot. So you need to make a lot, right? Sometimes it helps to make a matrix of scatter plots to kind of see everything, you know, at once. So you can do that here. The type of graph is called matrix plot. And for now, let's just dump everything in it. And you can change the color. You can change the color of the dots by conditions. So let's do that. So it will color code by different churn outcome. Look at that. But this is kind of too much, a little bit too much. But at least what do you spot? These graphs are those perfect linear correlations, right? And it's diagonal-wise, mirrored, right? So it's equivalent across the diagonal line. For a lot of these, usage variables like day charge, day calls, if they are not perfectly linear, like between day minutes and 9 minutes, what do you see? It's kind of random. There's no clear lines there. There's no clear correlations over there. That just tells me that this data set is partially fake. It's a toy data set by nature. It's a toy data set. It does reflect part of the world, but it doesn't represent the real sort of, the business cases behind. But it helps for you to learn exploratory tools and also data mining. There are some correlations there, but not a lot. For normal customer, what would you expect? If you make a lot of calls in a day, what about night? You may also make more calls at night. Typically, but it's not hard to imagine for a segment of the customers who make most of the calls at night, but not in the day, because typically with the telecommunication plans, night minutes are free, but that is 10 years ago. So 10 years ago, 9 minutes are free. Day minutes count as part of the quota. So over a month, you have 600 minutes for the day. So once you hit that limit, you'll have to pay for additional, or you have to upgrade the plan, which means more money. But night minutes are free, complimentary, because the demand is lower at night. So it's kind of a benefit of the plan. As versus if you buy a per pay phone, then you have to pay every minute, day and night, right? So that's part of the benefits of having the plan. That was more than 10 years ago. Now the calls are all free, right? Texts are free, calls are free. Data is close to free, but not yet. We're getting there. But it's getting cheaper because of internet. Yeah. So you cannot generate those graphs within the Stat Explorer, but after that you can still do that. No, it's not. It's about this node. It's about this node particularly. So if you try to do graphs within this node, you will have access to a different sets of information, but not the raw data set, but not the churn data set. But in every other node, let's say transform variables, I go to the results, I can do plot again, and I can see the same set of, I guess not. Yeah. So let me revise. Not always you can see the original data set. It's about some of the nodes. So to be sure that you can generate the graphs that you want, this is the best place to be. The Graph Explorer is to customize the graphs.